Welcome to the video on the isolation of essential oils from spices. The principal aim of this experiment is to provide experience with the extraction of essential oils from spices using distillation. Students will first isolate using distillation and then purify using extraction the key chemical compounds that contribute to the aroma and the flavor of some common spices. Distillation is the process of separating the components or substances from a liquid mixture by using selective boiling and condensation. Simply put, it is a separation based on boiling point. Steam distillation is a technique used to distill immiscible liquids, or liquids that are not mixable and or not soluble in each other. In this technique, the steam provides one of the immiscible phases and the spice is the second. The two substances mix in the gas phase and co-distill. But when cooled, the desired components separate from the water as they are immiscible. In this method, the steam is generated by heating the ground dry spice material and water in the distillation flask. This figure is correct except for that the heating method we will use is a heating mantle and a variac. The heating mantle is a basket that heats the round bottom, and the variac is the energy source. We will be using a water-cooled condenser where cold water is going in at the bottom of the condenser and out at the top of the condenser. Extraction is a separation process that consists of separating a substance from a matrix. Liquid-liquid extraction will be used in this experiment. We can pull a compound of interest out of a liquid if we use a second liquid that is closer in polarity to our compound. This is based on exactly how the analyte, or our essential oil, moves from the initial solvent into the extracting solvent. Simply put, this is a separation based on solubility. The essential oil molecules that we are extracting are nonpolar. They are going to not want to be in the water layer, but rather in the dichloromethane layer. So we will be using dichloromethane to pull the nonpolar compounds out of the water layer into the dichloromethane. For clarification, the water layer is the aqueous layer and the dichloromethane is the organic layer. In this lab, we will be working with fennel, cumin, cloves, cinnamon, caraway, allspice, and others as we isolate the essential oil from these spices. Okay, let's head to the lab. Once you select your spice, record its identity and its color and odor in your notebook. Weigh out approximately 4 grams of the spice. Grind the spice up into a powder using a mortar and pestle. Then pour that ground spice onto a pre-weighed weighing paper and record that mass that you will be using in this experiment. Now grab a 100 milliliter round bottom flask. Transfer your spice into this round bottom flask using your filter paper as a funnel, and then add 50 milliliters of water and a boiling stone. Set this aside to soak for at least 15 minutes before you start your distillation. While your spice is soaking, you can set up your distillation apparatus. Place your round bottom with your spice and water in it into the heating mantle. Fit it with a Y-shaped tube that also has a thermometer. The Y-shaped tube will then fit into your condenser. Remember, water goes in at the bottom and out at the top. The condenser will then be fit into the curved vacuum adapter, which will bring your distillate into the second 100 milliliter round bottom flask where you will collect your distillate. Notice that at each glass junction is a blue cack clamp to hold the glassware secure. Before you begin heating, please have your instructor check your apparatus to make sure that it is set up correctly. A photo of your setup might be a nice addition to your lab notebook. Once your instructor has checked your apparatus, you can begin heating. Remember that the heating mantle gets plugged into the variac and the variac gets plugged into the wall. That is how we are going to control the heating. If you have not done so already, you can turn on the water for the water jacketed cooled condenser so that we can start cooling that down. Continue distilling until you've collected 20 to 30 milliliters of your distillate. If your spice starts to boil up and froth into the condenser, then you should turn the heat down. Once you've collected your distillate, turn off the variac and heating mantle and turn off the water. All spice waste should be put into the proper waste container in the hood not in the sink. And then transfer your distillate into a small separatory funnel and extract with 10 milliliters of dichloromethane. If your 2 layers fail to separate, you can add 2 milliliters of saturated NCl and swirl gently.
You'll see 2 distinct layers form. It is your job to distinguish between your aqueous and your organic layer. As mentioned previously, your aqueous layer will be the layer that contains water, and the organic layer will be the layer that includes your organic material. You are also able to determine which layer is which by calculating the density of your compounds in your mixture. The layer that is more dense will always be at the bottom. You will need to invert the set funnel. This means that you must release the pressure inside the set funnel when the reaction is occurring. Releasing the pressure is also known as venting. To do this, you want to make sure that the cap of the set funnel is at the palm of your hand and that the valve at the bottom of the set funnel is closed. You then invert or shake the set funnel like this a couple of times. To release the pressure, you must make sure that the nose of the set funnel is facing away from you and is inside the hood. Once the pressure is released, place the set funnel back on the metal ring clamp and wait for the layers to separate completely.
You must first remove the top of your separatory funnel, and then you can drain the bottom layer into a beaker. Your bottom layer should be the organic layer, the methylene chloride that contains your essential oil. Use caution here to not let any of the top layer into the beaker while trying to get all of the bottom layer in. I probably could have gotten a little bit more of that bottom layer here. Set that methylene fraction aside and get ready for your next extraction. Add 10 more milliliters of methylene chloride to your separatory funnel. Cover it, shake it, and vent it, and shake it and vent it. Let your layers separate again. Transfer the bottom layer into that original beaker, adding it to your first fraction, and do that 2 more times for a total of 3 extractions with methylene chloride. Once you have all 3 fractions, about 30 mils of the methylene chloride, set it aside. Weigh out approximately 2 grams of sodium sulfate onto weighing paper. Pour it into your methylene chloride fractions. Mix it up, stir it around, jiggle it, and then let it sit for about 15 minutes. The sodium sulfate is going to sequester and bind to any water that may be around from that top layer of your extraction. When you're done with the 15 minutes, pour the mixture using gravity filtration into a pre-weighed round bottom flask, leaving the sodium sulfate behind and collecting through gravity all of your methylene chloride fractions. Once all of the methylene chloride has dripped through the filter into your round bottom, we will head over to the rotovap. Your instructor can help you here, but what the rotovap does is evaporate off all the solvent, leaving your essential oil behind. Once the solvent is evaporated, take the mass of your round bottom with your essential oil in it. That will provide your yield. However, if you cannot actually see any oil in your round bottom, then add 2 milliliters of methylene chloride back to your round bottom. Swirl it around, get that methylene chloride to get all of your oil out, and then transfer that 2 milliliters from the round bottom into a small glass vial, and we will then dry it using air. This is just a way of concentrating our oil so that we can see it. Once the methylene chloride is all evaporated off, you'll be able to see your oil in your vial. Once you get your product, you can cap the vial, label it clearly, and put it in the drawer with your instructor's name on it and save it for next week. Next week, we will be doing infrared spectroscopy on our samples. Don't forget to record all of your observations in your notebook, the smell of your oil. And now, safety with Jane.
Latex or nitrile gloves will be used when handling samples and chemicals. Insulated gloves should be used when handling hot materials. Considerable care should be exercised to prevent burns from the heating mantle and hot glassware. Heating mantle plugs into the variac and the variac plugs into the electrical outlets. Check the variac for frayed edges or frayed cords. Many of the substances you will be using in this lab represent moderate exposure hazards for ingestion and skin exposure. As with all chemicals you will be using, avoid contact with skin and ingestion. Wash hands after exposure and put all waste chemicals in the proper waste containers in the waste hood. Easy peasy.
There you have it, the isolation of essential oils from spices. This lab is one of the only times the organic chemistry lab smells good. Enjoy!